All right, in this video, we are going to look at how we can use the quadratic equation, ice tables to figure out equilibrium concentrations of a reaction. So look at our problem here. For the reaction shown here, where K is 0.513, we have N2O4 gas goes to 2 molecules of NO2 gas. So the first thing we want to do is write our KQ expression, which is NO2 squared divided by N2O4. We have initial concentration of N2O4.5, and we want to know what equilibrium concentration of N2O4 and NO2 are. So I'm going to start my ice table. Initial of N2O4 is 0.500. We don't have any NO2. Since we have no NO2, we must make it. So we will take away from our reactant to make products. We put the 2 here because of stoichiometry. Then I plus C equals E. So 0.500 minus X and 2X. Now we can plug into our KQ expression. So KQ is 0.513. That's going to equal 2x with that whole term squared. And 2x squared, by the way, is just simply 2x times 2x, right? So that is 4x squared divided by 0.500 minus x. Now, when we have an x squared term and an x term in the same equation, that's going to be your big hint that you should use the quadratic equation. Now, the way we can get around using the quadratic is looking for the x's small approximation, where we could get rid of this minus x term. However, our initial concentration and our equilibrium constant are about the same value, so that approximation is not valid. So I'm going to have to set this up to look like the quadratic. So let's do that. So I'm going to multiply each side by my denominator. And so I want to distribute the 0.513 in. So 0.513 times 0.5 is 0.2565. And that's going to be minus 0.513x. That's equal to x squared. Now I'm going to get everything on the same side. So I'm going to move these over, and we have 0 equals 4x squared plus 0.513x minus 0.2565. There's our A term, our B term, and our C term. All right, so now we get to solve the quadratic. So remember, there are 2 possible solutions. So x equals negative b, so negative 0.513. Let's do the addition one first. And that's going to be b squared, so 0.513 squared. Oops. Messed up on writing my 3 there, and I just lost my square root. 0.513 squared minus 4 times a is 4 times c is negative 0.2565. All of this is going to be divided by 2a. All right, since we have to do a plus and minus term, let's just do the square root. Let's knock that out. So when we knock that out, 0.513 squared minus 4 times negative 0.2565. And I'm going to square root all of that. So our square root term is actually 2.089. So if you follow along with the math, try to do this term and see if you got what I got. So again, that is 2.089. And I wrote 2a, and I should really write, we know what a is. That's 2 times 4. All right. So let's do the first solution where we're adding negative 0.513 to this number. So negative 0.513 plus 2.089. I'm going to take that number and divide by 8. So X equals 0.197. Now, there is another solution where I would have to subtract 2.089, but I can already know I don't need to do that. The reason why is that our B term is negative, and if I subtract 2, it'll just become like negative 2.5, or actually negative 2.6 divided by 8. X would be a negative term. I can't have a negative concentration, so it has to be my positive, right? And remember, the question says, what's the equilibrium concentration? In the ice table, that's E. So we know what X is now, 0.500 minus X minus 0.197. So N2O4 equilibrium concentration is 0.303 molar. And then for N2O, that's 2 times 0.197. So it's going to be just under 0.4. So at equilibrium, we have 0.394 molar for N2O. And that's it. I know it seems very complicated when you first start it, but if you realize you have to use the quadratic, just follow along the formula, and you should be able to get it no problem. As always, if you have questions, let me know. Otherwise, I hope to see you in another video here.